I want to next ask an elementary school question, which is this. After partitioning the interval from A to B into n subintervals with a regular partition, meaning intervals have the same length, we will choose an arbitrary value of x in each of these subintervals. And for me to compute the average of those n y values, I'm simply going to sum them together and divide by how many I have. But I don't want to stop there. What I want to do is ascertain how I can compute the average of an infinite collection of y values over some interval. To do that, notice this n has nothing to do with the index variable, so I can bring it into summation notation. I don't know if I said that correctly. I can bring it into the sum. My goodness. Looks somewhat familiar, but unfortunately there's not a b minus a there, so let me force it to be there. In mathematics, whenever I want something, create it out of thin air. Well, I shouldn't say whenever, but here I can. But then compensate. However, notice that the sum can be described as such. That is just delta x. Now, when I take the limit of this Riemann sum, it tells me that the average of an infinite collection of y values over some interval, if the curve is described by some function, can be interpreted as nothing more than this interval, with a coefficient out front. So let's see if I can't apply this. B is pi. A is 0. One more application.